Hello friends, let us start with Unit 9, that is uses and limitations of averages. As you already know about what are the averages, average is an attempt to find one single figure to describe whole of figures. And there are three mathematical averages we have started: mean, median and mode. One is the mean, the arithmetic average of all the numbers. Second is median, the value in the center when the numbers are arranged least to greatest. Third is the most commonly average is mode, the most commonly appearing value, that is mode, which we have already studied. In this unit, basically we will study advantages, disadvantages and uses of all three averages. So first is advantages of mean. It is simple to understand. It means it is simple to understand and compute. The data is not required to be arranged in ascending to descending order, as it is done when computing the median. So in mean it does not require to arrange the data set in ascending or descending order. So it is simple to understand. It depends on all values. It is affected by the value of every item in the series. Therefore, the mean can be said to truly represent the central tendency of the data. Next is rigidly defined. It is calculated by a rigid algebraic formula that does not depend on the discretion of the researcher. This is important because if we were not rigidly defined, then the central value would be affected by the biasness of the investigator. Next is, it is capable of further algebraic treatment. For example, if we are given the arithmetic mean and sizes of two groups, so we can find an algebraic formula for the mean of the combined group also. And this cannot be done for the median or mode. So this is the advantage of the mean. Next is mathematically significant. The average has many significant mathematical properties. It occurs in important theorems in statistics, such as the central limit theorem, which is widely used in the field of inferential statistics. Next is not affected by sampling fluctuations. It is reliable in the sense that it does not vary too much when repeated samples are taken from a big population for the purpose of estimation. So if we wanted to estimate the average height of the population of a country, it is enough to calculate the mean for the randomly chosen sample that is large enough. The sample mean will be a reliable estimate of the population mean. Next is measure of central tendency. The mean is a central value for the data in the sense that all the squares of the difference of the data value from a numerical value A are the least when A is taken to be the simple arithmetic mean. Next is weighted average. If some items in a distribution are more important than others, we can assign weights to them and calculate the weighted arithmetic mean also. So the concept of weight is not useful when calculating the median or mode. Next is, it has wide applications. It has application in fields such as economics, stock market, education and research. For example, we use arithmetic mean in order to calculate the expected future gains of our stocks. It is used in the field of education when, for instance, the teacher calculates the average score obtained by the students on a test. Next is uses of mean. It is used for various purposes in business, finance, research and everyday life, including: first is analyzing companies, like comparing stock prices over time, comparing two companies or comparing a company to the overall market. Tracking a population over time or comparing two populations. Next is researching effectiveness of a treatment, average time to recovery, average improvement in the key metrics. Next uses deciding when it makes sense to advertise on a platform. Means based on lifetime value of a customer, comparing two candidates for a sports team, academic institution or job opening. Making prediction based on the past data, mean and standard deviation to forecast a range of values. Unit price to compare two bulk packages of an item in the same store or at different stores. Next is advantages of median. As we know that median of a set of data values is an important measure of the central tendency of the data. It gives us information about where the center of the given data lies. We now list some advantages and disadvantages of the median as a measure of the central tendency of the data. So first is the rigidly defined. It means that there is a unique value of the median for a given set of data values. On the other hand, when calculating the mode, it is possible to have two values for the mode. Second is easy to understand. It is easily understood and easy to calculate. In some cases, it can be located mainly by inspection. Next is it can be computed graphically. It is possible to compute the median graphically by drawing histogram or ogives. It is unaffected by extreme values. It means it is not at all affected by extreme values. This is because the median of the data is calculated on the basis of the relative position of the data values. Since it is unaffected by the presence of extreme values, it is used when studying skewed distributions. Skewed means asymmetrical distributions. It can be calculated, next is can be calculated for open-end classes. We know that open-end classes means the first and the last figure is not given in the data set. So it is very useful to calculate median for open-end classes because in median we need central value. It is used for qualitative data. We can use the median to study the central tendency for qualitative data where characteristics can be arranged in ascending or descending order. On the other hand, the arithmetic mean cannot be used when studying qualities such as beauty, intelligence, etc. So this is the advantage of median. Minimize total deviation. It means what? The total absolute deviations of the data. Values from the median is smaller than any other value It means that median is the best candidate for the central value of the data set. So this is another major advantage of median. Now, limitations of median. First is ambiguity for even observations. In the case of an even number of observations, the median cannot be determined exactly. We merely estimate it by taking the mean of two middle terms. Next is, it is not based on all observations. For example, the mean of 10, 25, 50, 60 and 65 is 50. We can replace observation 10 and 25 with any two values which are smaller than 50. So our observation 60 and 65 with any two values greater than 50 without affecting the value of the median. So this property is sometimes described by saying that median is insensitive. That's why it is not based on all observations. Next is, it is not amenable to algebraic treatment. For example, given the mean of the two data sets, there is a formula for the combined arithmetic mean. On the other hand, given the median of two data sets, we cannot obtain the median of the combined data set. So it is a limitation of the median, but not in the case of mean. Next is sampling fluctuations. As compared with the mean, it is affected by fluctuations of sampling. Next is tedious for large data sets. Median requires little arithmetic, so they are easy to find by hand for small sets of data. But arranging even a moderate number of observations in order is very tedious, so finding the median by hand for larger sets of data is unpleasant. Next is, the median can be calculated for group data sets only under the assumption that the data values are spread uniformly across any given interval. Next is uses of median. It is the only average to be used while dealing with the qualitative data, means honesty, beauty, etc., which cannot be measured quantitatively but still can be arranged in ascending or descending order of the magnitude. For example, to find the average intelligence among a group of people. It is to be used for finding the typical value in problem concerning wages, distribution of wealth, etc. Next is, it helps us to identify if the distribution is symmetric or not. The mean and median of a symmetric distribution are close together. If the distribution is exactly symmetric, then the mean and median are exactly the same. And in a skewed distribution, means asymmetrical distribution, the mean is farther out in the long tail than the median. Next is advantages of mode. The mode is easy to calculate and understand. In some cases, it can be located merely by inspection. It can be estimated graphically from a histogram. Mode is not at all affected by extreme observation and as such is preferred to the arithmetic mean when dealing with extreme observations. Next is, it can also be obtained in case of open-end classes in a frequency distribution. On the other hand, the mean cannot be calculated if the frequency distribution has open-end class intervals. We already knew that what are the open-end classes. The first and the last one is not given in the data set. It can be used to deal with qualitative variables like honesty or beauty, etc. Next is limitations of mode. Mode is not rigidly defined. It is ill-defined if the maximum frequency is repeated or if the maximum frequency occurs either in the very beginning or at the end of the distribution, or if the distribution is irregular. So there can be two or more modes of a distribution. Next is, it is not based on all observation of the series. Means, since the mode is the value of x corresponding to the maximum frequency, even in the case of continuous frequency distribution, the mode depends on the frequency of the model class and the classes preceding and succeeding it. Next is, the mode is not suitable for further mathematical treatment. For example, from the model values and the size of two or more series, we cannot find the mode of the combined series, but in the mean it is possible. Next is, as compared with the mean, the mode is affected to a greater extent by the fluctuations of sampling. Next uses of mode is, it is the best measure of central tendency for highly skewed or non-normal distribution because it gives the point of maximum concentration of the data. It is used when performing non-parametric tests in inferential statistics. Now, selecting the proper average means which average is to be used and when. Arithmetic mean is an appropriate average for all situations where there are no extreme values in the data. Mode is an appropriate values in appropriate average in case of qualitative data. For example, the opinion of an average person is probably referring to the most frequently expressed opinion, which is the model opinion. Next is, median is an appropriate average in a highly skewed distribution. For example, in the distribution of wages, incomes, etc. So this is all the selecting of the proper average. Next is, now summarize the whole averages, their advantages, disadvantages and used for. So first is, advantage of mean is easy to find, uses all values, total can be calculated from it. And the advantage of mean is easy to find with ungrouped data, not affected by outliers. In statistics, outliers means a data point that differs significantly from other observations. An outlier may be due to a variability in the measurement and indication of the normal data. It may be the result of experimental error. So that figure are sometimes excluded from the data set. In case of mode, it is easy to find, not affected by outliers, and can average non-numerical data. Now, disadvantage of mean is outliers can distort it. It has to be calculated. And in case of median, does not use every piece of data because we use only middle figure. Next is in case of mode, it may not exist, does not use again every piece of data. Third one is used for, mean is used for every evenly spread data. Median is used for the data with outliers. Mode is used for non-numerical data and finding the most likely value. So this is all the summarization of all three averages, that is mean, median and mode, their advantages, disadvantages and uses of all three averages.